So we'll continue on with our GED and review. Again, my name's Brian Thomas, and this next set of questions will be involving fractions and decimals. Again, working with word problems, some things that we have to pick up on is what we refer to as knowns, some of the given information. The unknown, like I said, usually that's the last sentence in the question. The relationship, trying to figure out how the known and the unknown relates in the problem. An estimate's always good as far as just trying to get an idea of how to roll out some of the answers. And then, of course, setting and solving is a big thing. And remember, you are allowed to use a calculator for most of the GED tests. And lastly, when you do use your calculator and look at your answer, sometimes with subtraction or division, we can put things in backwards, and that can cause a problem. Make sure your answer makes sense before you move on. So let's look at this first word problem here. Again, feel free to pause the video and work ahead of me, and then unpause me when you're ready to kind of look at the way I did it. So we have a wooden flooring strip is 20 1/2 inches long. If you cut off 4 3/4 inches from one end, what will be the new length in inches? So this is kind of a straightforward problem. The known is we have 20 1/2 inches to start with. Cut off kind of means removing this 4 3/4 inches from one end. And what will the new length be? So that's our unknown is the new length. But we kind of can see the relationship is the knowns have to be subtracted to get the unknown. So basically what we have is 20 1/2 take away 4 3/4. So what makes this a little tricky is the fractions. If you have a GED calculator, there's a nice button on the GED calculator that is right above the N over D button. You have the N over D button, and then there's right above it is the U N over D button that can actually type in what we call mixed numbers. So that's one way of doing it is you have to kind of go green to get to that function right above it there. Now, I don't have a GED calculator, but I do have a little bit of relationship between some of the fractions and decimals. I do know that, a half is the same thing as 0.5 or 0.550 or 0.50. Because I know like in money, half of a dollar is like 50 cents. So either 0.5 or 0.50. I know a quarter of a dollar is like, 25 cents or 0.25. So 1/4 is the same thing as 0.25, which means 3/4 is like 3 of those. So 3/4 or 0.75. So I do know these relationships between fractions and decimals. So instead of using 20 1/2 take away 4 3/4, I can change it to 20.5 take away 4.75, 4 3/4. Since those are equivalent, now I can actually just lean on my calculator for the math. So 20.5 take away 4.75, and that gives me 15.75, which leads me to this 15 3/4 as a solution on that problem. What happens to a lot of people is they see this 20 minus 4 and they get this 16, and this 1/2 and 3/4, they're thinking a quarter. But notice this is a half take away 3/4. So that's not really the same thing as 3/4 take away half. So this kind of gets some people in trouble. It's safer either to use the calculator using the U and over E button, or you actually can just change them to decimals and just let the calculator worry about the rest of it. You don't need a fancy calculator for that. So that's some of the strategies to watch out for. 16 1/4 is a a trap for some folks. You have to watch out for that. And that's why using the calculator is kind of important in working with some of the fraction math. Let me clear this off. So another question we have again is, unleaded gasoline sells for $2 and basically about 87 cents if I round it there. How much would 10.5 gallons cost? Round your answer to the nearest cent. So again, if I read that more carefully, unleaded gasoline sells for $2.869 per gallon. Again, that means 1 gallon. Per gallon means 1 gallon. How much would 10.5 gallons cost? So again, if I'm using estimation, $10 and $2 and I can say it's about 287 if I round it, and 10.5 would be close to 10. And if you multiply by 10, that's going to give me like $28.70. So right now, based on that, the 1340 is way too low. The 301.20 is too high. The 28.69 and the 30.12 would be estimates there. Now, if I want to get the right answer, we don't have to really change the math at all. We can just let the calculator do it. So I can just leave it as 2.869. And when I multiply by 10.5, remember 10.5 is the same thing as this 10.5. I can change those fractions to decimals since they're friendly that way. And then I can let the calculator worry about the rest of it. So 2.869 times 10.5. So 30.12. So notice how it kind of rounds to the nearest cent. And they did say round your answer to the nearest cent. So $30.12 would be our answer on that one. So $30.12. So again, the knowns, and since I drive a car, I'm kind of familiar with, the price per gallon and the number of gallons. That relationship would be a location problem. And then we can kind of work from there. Now, if you're not really good with recognizing some of the relationships, there is what's called a proportion. So I could go like 2.869 per, which is a fraction bar, 1 gallon. So it's $2 and that much money there for 1 gallon. And if I set up a proportion, what I can do is put an equal sign here, and I don't know how much it's going to cost for 10.5 gallons. And in proportion math, again, instead of using a question mark in algebra, a lot of times we'll use an X instead of a question mark. And in algebra, in a proportion, the cross products must be equal. So if we cross multiply, we're supposed to get the same answer. So 1 times something must be the same thing as 10.5 times 2.689. So if I do the math by using cross multiplication, so we have 1 times x, and then 10.5 times 2.869. I wonder if that's still on my calculator. Yeah, that's going to be that 30.1245. Let's see if I can write that down. 30.1245. And remember, in algebra, 1x is really the same thing as x. So that, in other words, that's the unknown. And since it says round to the nearest penny, that's the hundredths place. So that's going to be not $30.13, but it's going to round down to $30.12. So it does check out there. So you also can use what we call a proportion, 2.869 per 1, something like that. And then we don't know the number or the price per 10.5 gallons. And there's what's called a cross product that can be used to solve the problem as well. Okay, let's see if we can get this all cleaned up. So our next question, Linda's paid $8 an hour. Notice how, again, they keep hiding a number on us. There's a lot of singulars. So an hour means 1 hour again. So you have to really kind of pay attention to those details there. An hour, that means 1 hour. If she earned $258 in 1 week, how many hours did she work? So basically, we know that the knowns are $8 an hour, and we end up with this $258 altogether. And what I pick up on is we don't know the number of hours she worked. The relationship, though, is what you get paid per hour. If you multiply that by the number of hours you work, that's going to give you your total pay. So the relationship comes together as, your hourly pay times the number of hours you work gives you that 258. So, 8 times something must give me this 258. Those answers all kind of look close together. So what I could do is, try these one at a time. But what I can also do is go backwards and use division instead. So instead of using multiplication, I can do the problem by reversing it and using division as my tool. So if I go 258 and I divide that by 8, that gives me 32.25. And we talked about that 25 is like a quarter. So 32 and a quarter, that's going to lead us to C as our answer there. So 32 and a quarter. So an estimate's not real very helpful here since the numbers are all so close together. Now, something else we can do is, again, use a proportion concept. Notice how it's $8 in 1 hour. What we know is 258. We just don't know how many hours that is. So notice how it's $8 in 1 hour. And it's $258 in, we don't know how many hours that actually is. And in proportion math, we are allowed to cross multiply. So we got this cross multiplication to come into play. So that has to equal each other. So 8 times some number must equal 1 times 258. So 8 times x must equal 1 times 258, which is 258. And we're really back to the same spot that 8 times something is 258. So I have to go backwards and divide to solve that problem, and we'd still end up with that 32.25, or in other words, 32 and a quarter. So proportion could also be used when you see this $8 an hour or $8 per hour. That word per means I can use a ratio. They kind of had that on us in that problem, but you could have used it if you wanted to. So on this question, we have a developer plans to build 20.5 acres. Let me try again. A developer plans to build homes on 21.5 acres. She estimates that 6.25 acres will be used for roads. The remaining land will be divided into 1/4 lots. How many lots can the subdivision include? So a lot of information here. So again, a developer plans to build homes on 20.5 acres. She estimates that 6.25 acres will be used for roads. The remaining land will be divided into 1/4 acre lots. How many lots can the subdivision include? So some things we pick up on is, on this problem is the remaining land will be divided into 1/4 acre lots. And then they're asking for how many lots can the subdivision include. So the remaining kind of implies that there's a subtraction concept going on. Well, we start with 20 and a half acres, but I have to remove some of the land because we're going to use it for roads. So some of the knowns have to be put together to start with. That 20 and a half is the same thing as 20.5, and 6 1/4 is the same thing as 6.25. So to start with, my knowns have to be put together to find another. It's an unknown, but it's going to now be known. Let's see what we can come up with here. So if I clear that off and go 20.5, and if I remove the 6.25 from that, that gives me 14.25. So 14.25 is the remaining amount of land. Now what we're going to do is we're going to divide that into 1/4 lots. So we have this 14 and 0.25, and we got to divide it into 1/4 lots. So we have that kind of going on. Now remember, if I'm using some reasoning skills, if I represent this as an acre, 1/4 means to cut this into 4 equal increments. So 1/4, each one of these is going to be 1/4. And what we pick up on is there are 4 1/4 lots in 1 acre. So what this also tells me is there really are 4 lots I'm going to build on each acre if I'm using some math reasoning. So using estimation, I've got 14 and then some more. All I got to do is multiply 14 times 4, and that's going to give me an estimation. So if I clear that off there and go 14 times 4, so that's getting me around 56. So what I'm picking up on is, the 107 is way too high. The 7 is too small. The 57 is looking really good because I have another 1/4, which means I can put one more lot on there. That's going to be that 57. You also could actually just type into your calculator 14.25. If you just divide that by 0.25, that would be probably the easiest way to do it. Just do that division, letting the calculator worry about it. So if I do the calculator 14.25 and I divide it by 0.25, that does give me my 57. So that math does play out there. Okay, so the catch is on this one is that remaining land is that 14 and 1/4. They don't give you that piece of information. We have to go find it. So it's an unknown that we need to find the other unknown, which is how many lots are there. So that's what happens on some of these problems is you have to find another piece of information before you start to solve the problem. So yes, 57 lots would be our choice there. So I'll clear this off again. So let's look at this one. A school buys 1,000 whiteboard markers. Below is the price per marker. Again, notice how they said per marker. They're not making that real clear, but there's a 1 there per 1 marker. They keep hiding that on us. For 2 brands. How much did the school save by buying brand X instead of brand Y? So again, the school buys 1,000 white markers. The price per marker is listed. So brand X is 27 cents per marker. and brand Y is 36 cents per marker. And what they want to know is how much the school can save by buying brand X instead of brand Y. So on this one, again, we got some math to do. What I need to do is find out how much it costs for 1,000 markers. So that known there has to multiply by the price for brand X. So since I've got 27 cents per marker and I buy 1,000 of them, I have to figure how much that actually costs. And again, if you multiply by 1,000, all you do is multiply, all you do is slide the decimal over 3 places to the right, and that would be 270. Or you can put that math in the calculator, 0.27 times 1,000, and it would give you 270. Then you got 36 cents. And if you multiply that by 1,000, again, if you multiply by 1,000, all you're really doing is moving the decimal 3 places to the right, and that would be 360. So notice how brand X is cheaper. How much do you save still requires us to do some subtraction. So 360 take away 270 would be our answer to that one. So if we let the calculator worry about our subtraction, so again, not afraid to use the calculator. 360 take away 270, and that gives me then 90. So I would be saving $90. So that one you really estimate doesn't really even come into play on that one, because by the time I do the math, the math is already there and we're there. So on that one, picking up on the knowns here have to be multiplied together to find some new numbers, and then these new numbers help us find the unknown of how much we saved. Again, that does make sense in this problem as well. So the setup kind of takes care of itself as we move through that problem. So that's all about really reading and comprehending on that problem. You could, again, use a proportion, but I don't think that is really necessary on this one as much. So let's clear this off. And let's go to the next one and see what we got here. So again, those fractions jump off at me. I'm like already kind of nervous about this one because I see A, B, C, and D are all fractions. Great. Let's see what the question actually says, though. A minor league baseball stadium has 6,000 seats. On team T-shirt night, the stadium sold 5,500 of its available seats. What fraction of the seats were sold? So again, the unknown here is we're looking for a fraction. Fractions are sometimes what we call ratios. So what I'm picking up on is there's this part to the whole amount. That's fraction language. So the part that was actually filled was 5,500 out of 6,000 seats. So what that creates is this fraction, 5,500 out of 6,000. So this part over whole comes into play. Again, if you have the GED calculator, there's this N over D button that you can take advantage of, and the calculator can do all the work. I don't have that calculator available with me here, but I do know a little bit of math, and one of the things I can do is I know in fractions these zeros can just divide out, so all I'm left with is a 55 and a 60. Well, a 55 and a 60 since they end in a 5 and a 0, that tells me that I can take out a 5. So when I have this 55 and this 60, since they end in a 5 and a 0, I can divide each one of those by a 5. So when you reduce fractions, you have to divide the numerator and denominator both by 5. And then that's going to equal out then, let me get my eraser out there. Got a stray little marker. All right. That's going to equal out then. So 5 goes in 55, 11, and 5 goes into 60. That would be 12. So 11/12 would be the result. Again, an estimate really doesn't do me very good there on this one. I have to pretty much do the math there. So sometimes that just falls off the table. But here, the knowns are actually signaled to be in a fraction form. The catch is who's the numerator and who's the denominator. Well, the part is the available seats that were sewed. That was the part that was actually filled. And the available seats was actually the whole amount, which was 6,000. And then with a little bit of math here, I can drop the zeros out. I can divide the numerator and denominator both by 5 to create a fraction that means the same thing, which is 11 out of 12. Or again, on the GED calculator, I have this N over D button that you can take advantage of. So our next question, Bob and Callie have until 1 p.m. to load 250 boxes. By 12:30 p.m., 175 boxes have been loaded. What fraction of the boxes has not been loaded? So again, notice that it's not a really big problem. So reading it nice and slow is to your advantage. So Bob and Callie have until 1 p.m. to load 250 boxes. So that's how many they have to load. By 12:30 p.m., 175 boxes have been loaded. The question, though, is asking what fraction of the boxes has not been loaded. So I know their goal is 250 boxes, and they've loaded 175. So if I subtract those, that's going to tell me how many boxes are left to be loaded. So I got to do some math there to find out, because it says has not been loaded. So I have to subtract those to determine that. So I'm going to use my calculator again. Subtraction is not my favorite thing. So 250 take away 175. That's going to give me 75. So 75 boxes are left to be loaded. They have not been loaded. But what I want to know is what fraction of the boxes have not been loaded. So again, we have this part, the portion that's not been loaded, which is the 75. The bottom is the base amount or the whole amount, which was the 250. So what I have is the 75 over 250. Now, again, if I have that N over D button on my calculator, I could reduce those. I don't have that, but I do recognize this is quarter math. I can divide the numerator by 25 as long as I divide the denominator by 25. And I do know that there are 3 25s and 75. And 25 times 10 would be 250, so that's a 10. So it's going to be 3/10. So B would be our answer. Again, with fraction math, an estimate's not really very helpful to me, except for the fact that only thing I do know is 175 out of 250, that's what's been loaded. That's actually more than a half. So what's left would be less than a half. And the only two fractions that are less than a half would be 1 out of 5 and 3 out of 10. 3 out of 5 is actually more than a half, and 7 out of 10 is actually more than a half. So that was the only thing I could pick up on there as far as the estimate goes is I have less than half to be loaded. So those are the only two that would be less than a half. So again, what's missing though is the 75. That's what's not been loaded, and that becomes my part out of 250. So again, that's what's you have to watch out for is there's an extra piece of known information that I have to find before I can solve the problem. So some of the knowns are blended in to the problem to help us find the final unknown in the problem. So that's our answer to that one. Okay, let's see what else we have here. I think we're getting down to the last ones here. Not very many left here. So let's see what we have here. So William is driving about 380 miles from Los Angeles to San Francisco. He plans to cover 3/4 of the distance before lunch. How many miles does he plan on driving before lunch? So again, he's going to drive 3/4 of the distance. So what I'm picking up on as far as known information, he's going to drive 3/4 of the 380 miles because that's the distance that we're looking for. So these kind of work together, 3/4 of this. So 3/4 of 380. How many miles does he plan to drive? So what I got to do is figure out what is 3/4 of 380. Well, I could do half of 380 because I know I take half of something. To take half of something means to divide by 2. So if I use that as an estimate, if I go 380 divided by 2, that'll give me half. So I got to go over 190. So to me, my estimate tells me that the 95 and the 126 have to fall out of the problem because 3/4 is more than a half. So I'm down to the 285 and the 254. To do 3/4, what you got to do is you got to divide the 380 into 4 pieces. So 3/4 means to cut it into 4 pieces. So if I'm going to do that using a calculator, that's 380 divided by 4. That don't look right. So 380, that's still not working. 380 divided by 4, that's going to give me 95. So each piece is going to be 95, but I get 3 of those pieces. So I get 3 95s. So if I go 95 times 3, now you can kind of see where some of these numbers are coming from. What's 95 times 3? So times that by 3, and I end up with 285. So 285 would bring me to A. So that's one way of doing the problem, is kind of figuring out that, half of 380 is like, what do we say that was? Like 190. So that rolls out 2 of the answers. To do 3/4 means to cut the 380 into 4 equal pieces, which would be 95s, and I get 3 of those. And that would take me to the 285. Now, another thing we can do is the word of in fraction math like this means to multiply. So what I also could do is go 0.75 times 380 if I remember that the word of actually can imply multiplication. So 3/4 times 380 will give me my answer. So if I use my calculator there, I can go 0.75 because 0.75 is the same thing as 3/4 times 380. And that does give me then that 285. So that does check out of that 285 there. So that would be our answer to that one. And then let's see what else we got here. So again, we have how many miles would a map distance of 5 inches represent if 1 inch equals 240 miles? So this one can be tricky for some folks. Notice that, 5/8, because I know that 4/8 would be a half, because 4 out of it would be half. So 5/8 would be more than a half. Well, a half inch would be like half of 1 inch. So half of 240 would be 120. So to me, the answer's got to be a little bit more than 120. So what I can probably rule out is probably A and D. So I'm really down to this 130, this 150. Now, 5/8 is not a fraction that I'm familiar with. So what I can do is divide 5 by 8 on my calculator to make it a decimal. So if I clear that off and go 5 divided by 8, that gives me 0.625 inches instead, because that fraction is not very friendly to me. So I can go ahead and just divide it out and make it a decimal. Now, if you got the GED calculator, you got a special button to do all that with. So this is really the same thing as 0.625. Oops, that don't look right. So we have 0.625. Again, one of the things we've talked about is there's this proportion math. What I can say is, 240 miles kind of goes with 1 inch. I can write that as a ratio. And we don't know how many miles goes with 0.65 inches. And in proportion math, what we're allowed to do is we're allowed to cross multiply. So when I have a scale problem, I can use a proportion. So the 240 goes with 1 inch, and then we don't know how many miles goes with 0.65 inches. So we don't know how many miles that is. And again, what's important with proportion math is your units have to be on the same side of the fraction. Since I put miles on top, inches on the bottom, over here I still got to do miles on the top and inches on the bottom. So the math says, go 1 times x. Well, 1 times x is just x. And then all I got to do is go 0.625 times this 240. So if I clear that off, well, actually I didn't have to, 0.625. If I multiply that by 240, that would give us our answer of 150. So 150 miles would be that answer. So one way of doing that is using a proportion. The estimate only gets me so close on that one. And I really don't know any other better ways than that at this time. That's my best strategy. May not be the best, but that's what I'm seeing there. All righty. Thank you for your time. Hopefully these videos were helpful. And I will continue to build a few more videos in my GED review. So stay tuned.